Hello and welcome to the next tutorial. In this tutorial we will be going over filtering your data in Formable. This is going to pick up from the last tutorial, which was importing geometry. So following along we'll have our New Hampshire data loaded from FIA as well as our polygons that show the national forest boundaries. Let's go ahead and jump right in. So my Formable is still open here. I'm going to come here to Formable. Here we can see our polygons and then our New Hampshire data. It's awesome. So to filter your data, you're going to come up here and click on the Filter tab. So what you're going to see when you first launch it is a basic and advanced panel and the number of plots that you have currently selected. As well as in the bottom right, you'll have an Apply Filters and Declare Filters button. So before we get into the filtering, it's important to note that the number of plots that are available for filtering, if you're using FIA and the validation IDs, will be only the plots that meet that validation ID. So if you're taking the latest current area, current volume plots, that's what you'll be filtering with. So if you want to access all of the FIA data plots and do your own filtering, you'll have to not use a validation ID. But that's only if you're using FIA. If you're not, it'll just use all the data that you currently have. Okay, so in the basic filtering, what you have are your filter controls. So any column in your data set, you'll be able to control here. You can choose different values, and for continuous data, there's sliders. Let's start really easily. Let's say we want to pull out from New Hampshire county codes 5 and 11. You can select those, you can apply our filters, and it will immediately pull out the 157 plots that meet the criteria. We can check it on the map, and we can see, oh, there are 2 counties that have been selected out of our data, which is cool. If we want to clear that, we can clear our filters. It's going to clear the filtering. Let's do something else. For example, let's say we want to pull out a scientific name, all plots that have a sugar maple on them. You can select scientific name, apply the filters, look at the map, and we can see these plots have changed to be just the ones that contain sugar maple. So again, basic filtering is quite basic. Our filtering is, again, plot-based. You're not removing rows from your data. What you're doing is you're selecting plots based on criteria. So for basic filtering, you can really only do a couple additive AND statements. It's not very useful. So what we have for more advanced users, people that want to get specific into the weeds of their data, we have an advanced filtering plot. Not advanced filtering plot, excuse me, advanced filtering tab. So in the advanced tab, we designed this to be very similar to ArcGIS's clause builder. And so what this is going to do is it's going to generate SQL code that runs on the DuckDB database and gives us back the plots that we're interested in. So we can start with adding a clause. So let's say we can add a clause here. We want to say it's a row-based. So within the rows of our plot, let's say we want to find all plots that contain, let's just say field age is, you can choose a logic here. So out of all of our plots, the age is greater than or equal to, let's say, 50 years old. We can go ahead and apply this. We can see we have 958 plots that have a field age greater than 50 years old, which is cool. So that's awesome. If we want to clear the query, we can click Clear Clause, and it will return us back to the original data. So again, we can do simple row queries. We can do the same thing we did in the basic filter, like county code is equal to 15. You can apply that. 7 plots. You can see it pulls out just that county. That's what the basic row filtering does. You can use any sort of logic to pull out what you want, filter null variables, etc. You can also delete the clause here as well. Go ahead and clear that. And so let's do something else. So we have our rows. Let's say we want what we call group match. So within a plot, if you want multiple criteria that are not mutually exclusive, you can do something like this. So we can say within our plot, we want to group by plot key. So within our individual plots, we want to find all species that are equal to, or that have a sugar maple and a red maple. So let's say within the plot, we want all scientific names that contain a sugar maple add another clause. You can do another group match. So within the plots, scientific name is equal to red maple. So now what we're saying is within our plot key, we need a plot to contain both a sugar maple and a red maple. So we can go ahead and apply this clause, and we get 350 plots. If for some reason you want this to be an OR, so it can contain either a sugar maple or a red maple, you can change the type here to be OR, you can apply that, and you can see we have more plots, because that makes sense. Or doesn't have to have a sugar maple, but it has to have a red maple. Doesn't have to have a red maple, it could have a sugar maple, or it could have both of those. So depending on what you want to do, you can mix and match these here. So we're saying, okay, all of our plots have a sugar maple and a red maple, so they must contain both of those species on a single plot. We can mix this with row plot, so we can say we also want to have in the county of these random counties, we can pull these out, apply clauses, so we have 95 plots. You can check the map, we can see these are all the plots that have a red and sugar maple and fall in these counties, which is pretty cool. Let's say we're interested in something like the diameter of these plots, or like the quadratic mean diameter, basal area, or TPA. We have another type of clause, which is the group aggregate clause. So, okay, so we have all these plots here that meet these criteria. Within those criteria, say we want to aggregate the plots. So within all of our plots, we want to look at the plot key. So within all the plots, we can either have the number of rows, the sum of a variable, the average, min, max, TPA, BPA. Let's say we want in our plot, we want the max diameter to be less than, let's say, 20 inches. If we apply this, we can see we have 47 plots where the max diameter is less than 20 inches inside of our plots that contain a red and a sugar maple inside of these counties. And let's say within those that group aggregate, we want to have a certain variable that's describing this. So let's say plots with the diameter less than 20 inches maximum, and within that, let's say we want our owner group code, so our ownership to be equal to private land. We can also do that. We can say owner group code is equal to 40. This is FIA stuff. It's not really too important. Whatever your data has, you can use. We can go ahead and apply this. And now, basically, we built this statement out that says, okay, we want all plots that have a red maple and a sugar maple on them that are within these counties. And now, within those plots, we want the max diameter to be less than 20 inches within private land. So you can essentially mix and match this however you want and build whatever sort of statement you want. And so the cool thing about this is if we go to our map, no, my kitty is complaining. Be there in a second, kitty. You can see exactly the plots that meet that criteria. And you can go ahead, you can save the code that is used to generate the SQL statement and reuse it. So you can build up a pipeline of filtering that you want to use again. You can go ahead and you can do this. So you can click on Save Query, and I can save this to my demo folder. Just going to save a text document that, so I downloaded it. It's going to save a text document that will take that query, save it, and assuming you have the same columns, will let you reuse it and pull out just those plots. So to demonstrate this, I'll clear my clauses. I'm going to reset it back to default. You can see all the plots are here. I can go back in and click Load Query, and I can find the text file that I just saved. I can open it back up, and it's going to, again, pull in the code, filter the tables, and return just the plots that you're interested in, which is really cool. So you can spend time building a statement up, save it, and reuse it as many times as you want with either the same data set or different data, and it will give you the same result every time. So that is how the filtering works. Yeah, you have group aggregates, you have group matching, and you have row-based filtering with and or statements, and you have all the logical operators. And if you don't want to do things like diameter or max, you can do things like TPA, BPA, quadratic mean diameter, anything you want. You can, again, subset by a certain variable. You can really mix and match your statements to get just what you want out of your data. So this is the filtering portion. I'll leave it at this, and in the next tutorial we'll go over mapping.